joining us today. It is so good to have so many of you here with us in Austin. This is our first live product launch in a couple of years. And also welcome to all of you who are joining us online. We have some great new products to show you today. So, at AMD, we're all about high performance and adaptive computing and using our technology to create solutions that solve the world's most challenging problems. And from cloud services to 5G networks to AI to automotive, PCs, and much, much more, we're really touching everyone in terms of touching billions of people every single day. Now, today marks the beginning of an exciting new chapter for AMD. Over the next several quarters, we're going to introduce 4 new architectures to the market, and that's across more than a dozen products. So it's really just an incredible pace of innovation. It's more than we've ever done before. And we're going to start today with our new Zen 4 core that spans from high-end servers to desktop PCs to notebook PCs. We're going to also talk a little bit about our upcoming RDNA 3 gaming graphics architecture, which will bring another significant increase in performance and performance per watt for the most demanding gamers. And our Zen 4 C core, that's optimized for cloud-native computing, as well as our next-gen AMD XDNA architecture that we're also all looking great and on track to launch in 2023. Now, at AMD, we love the PC, and we especially love all of the PC gamers and enthusiasts around the world who push us to continue to build the best possible for CPUs and GPUs. We've been focused on delivering just outstanding experiences with our combination of hardware and software, and we're partnered with the world's top OEMs to deliver innovative new form factors and new system designs. So today is all about our next generation of Ryzen processors that will push the envelope for gamers, creators, and enthusiasts. So let's go ahead and get started. Now, for our next generation Ryzen CPUs, we set very ambitious goals. You know that about AMD. We wanted to make the Ryzen 7000 series the fastest CPU for gamers while delivering the most compute for creators. We focused on a new CPU core design that combines both leadership performance and leadership energy efficiency. And we also wanted to take a big step forward with an all-new desktop platform that scales into the future. So to deliver on all these goals, the Ryzen 7000 series is the first 5-nanometer CPU for desktop PCs. Ryzen 7000 is both extremely performant and also extremely power efficient. And it has an all-new AM5 platform that supports the latest I/O and memory technologies, including PCIe Gen 5 as well as DDR5. So it all starts with our new Zen 4 core. Our designers have done it again. We've exceeded our performance goals for Zen 4, and that allows us to deliver leadership core performance. Now, earlier this year, we estimated that Zen 4 would deliver an 8 to 10% uplift in IPC compared to Zen 3. And I'm extremely excited to say today that as we optimize the product for production, we now see 13% more IPC in desktop applications. Now, we also designed Zen 4 for high clock speed. So from a frequency standpoint, we've increased the frequency at the top of the stack to 5.7 gigahertz. That's 800 megahertz higher than we did in Ryzen 5000. And as a result, Ryzen 7000 single-threaded performance is up 29% higher compared to Ryzen 5000. These are just huge performance increases, and I'm extremely proud of what the team was able to deliver. Now let's look at our top-of-stack Ryzen 9 7950X. We have 16 cores, 32 threads, up to 5.7 gigahertz boost, an 80 megabyte cache, and 170 watt TDP envelope. The 7950X is simply going to be the best CPU for gamers and for creators. So let's take a look at some of the performance. If you look at the performance in 1080p gaming compared to the 5950X, the 7950X delivers on average 15% more performance across a range of popular games, and that comes from the single-threaded performance increases. Now, for creators, the combination of our Zen 4 core and our AM5 platform delivers on average more than 40% compared to the 5950X. And that's where you really see the content creation capabilities come alive. Now, let's compare to the competition. You can see that the Ryzen 7950X is the fastest CPU in the world. In 1080p gaming, the 7950X is faster than the competition across a wide range of games. And for creators, the 7950X delivers up to 62% more compute performance. So let's take a look at the 7950X actually in action. Here, what we're showing is a time-lapse demo of the popular 3D modeling and simulation software V-Ray running a built-in gaming benchmark, rendering benchmark. And on the right side is the 7950X, and the left is the competition. As the demo completes, we see that the 7950X scores over 30,000. That's 62% higher than the competition. Now, this is a tremendous increase of performance for creators, enabling them to spend more time creating and less time waiting for their images to render. But there's another very important thing about this demo. Not only does the 7950X deliver 62% higher performance, it achieves this performance at 47% better performance per watt. That's 47% better performance per watt. So that leadership performance and energy efficiency really highlights why we're so excited for gamers, enthusiasts, and creators to really get their hands on our new Ryzen 7000 CPUs and AM5 platform. Now, in addition to the 7950X, we're also announcing 3 more Ryzen 7000 processors today, ranging from the 12-core 7900X to our 8-core and 6-core 7700X and 7600X. And these will all bring the leadership performance of Zen 4 across all price points. Now, in fact, if you look across this stack, what you see is that all 4 of our new Ryzen 7000 CPUs deliver faster single-thread performance in Geekbench than the competition. And as everyone knows, faster single-thread performance is great for gaming. So let's take a look at our mainstream 7600X and how that compares to the competition. Here you can see the Ryzen 7600X on the right and the competition on the left, both running F1 2022. And while you see smooth gameplay in both cases, the 7600X consistently delivers significantly higher frames per second. In fact, by the end of the benchmark, what you'll see is that the 7600X is actually 11% faster. That's our mainstream price point against the competition's best. Now, if you look across a broader set of games, the mainstream 7600X delivers on average 5% faster gaming performance. And that's really, when you look at it, just an incredible capability at our mainstream price point. So hopefully you can now see why we're so excited about Zen 4 and how it really is the fastest core in the world for gamers. Now, to tell you a bit more about the leadership Zen 4 core design, let me bring AMD CTO Mark Papermaster to the stage. Mark?
Thank you, Lisa. Well, it was a decade ago that we launched the design effort of our first Zen processor, starting the whole Zen family. And we set a goal to return AMD to sustained high-performance CPU delivery. In each new CPU generation, we've launched first with our Ryzen desktop, where our gaming and content creation customers really thrive on performance. When Zen 4 debuted in 2017, it just disrupted the industry with the significant IPC, performance, and energy gains that we were able to deliver. Zen 2, really brought with 7 nanometer an incredible compute efficiency. And then Zen 3 with its grounds up new architecture, delivering impressive high performance leadership. And now I could not be more excited than to introduce our new generation of Zen for Ryzen desktop products. Zen 4 continues our tradition of delivering new CPU performance that delivers high performance right on schedule. The result gives desktop users the generational high performance they need and have come to expect from AMD Ryzen CPUs. Our on-schedule high-performance delivery has enabled AMD to become a trusted supplier to our customers, and Zen 4 delivers again. Let me spend the next few minutes just walking you through a little bit more of the detail about how Zen 4 delivers that performance, leveraging both design improvements and the 5 nanometer leading edge technology node. We have several architecture and technology improvements compared to Zen 3. I'm pleased to share that Zen 4 brings a significant instruction per clock uplift, 13%. We've added a new front-end design to better feed our execution pipes. For machine learning and high computation workloads, we have expanded our x86 instruction support to include AVX 512. And lastly, we leveraged the most cutting-edge process node along with AMD design efficiencies to bring these significant performance and energy efficiency gains. Look, let's start with always the first measure of a new CPU microarchitecture, because it's always starts with how efficiently a processor can get the job done at each clock tick. That's IPC, instruction per clock. You know, I'm often asked if we used up all the tricks in the book for CPU performance, or is there still levers at the ready for our ongoing roadmap? And you all know the answer. At AMD, we thrive on innovation, and you see that persist in each generation delivery across our Zen roadmap. Zen 4 brings a geo-mean of 13% instruction per clock improvement using typical desktop applications, and let's break that down. This 13% improvement versus Zen 3 is a geo-mean, so we are looking at 22 representative workloads across gaming, content creation, computational benchmarks that we show here. And as we did in the transition from Zen 2 to Zen 3, we felt it was important to show you a really holistic view of how the desktop workloads respond to the changes we've made in the core. I'm also pleased to show that many of the gaming workloads really demonstrate a disproportionately larger set of gains in Zen 4, and that, again, corresponds to the design changes we made. Our cumulative IPC improvement over that Zen era, over that 4 generations, demonstrates our relentless focus on core performance, because it's delivered a 235% IPC gain over that period. Our focus on core performance is simply relentless. Zen 4 is a derivative of Zen 3, so we targeted, of course, enhancing on that base of Zen 3, building on the success. With Zen 3, we increased the execution width, and so at Zen 4, it became important for us to work on how we feed the instructions even faster into the machine. And that's why you see most of the improvements coming from the front end and branch prediction. Really, that makes up almost 60% of that IPC gain, increasing the capability of more instructions per cycle. We grew the op cache over 1.5x to increase the hit rate and deliver more ops per cycle. The load store has improvements, and a larger L2, a doubling of the L2, provide critical data faster, leading to that overall 13% IPC. So AMD has also long supported the advanced vector extensions in x86. And in Zen 4, we're excited to add support for AVX 512. When going to such a wide vector width, we took very careful design consideration to avoid impacting the performance when you have that high switching activity of those wide vectors. So what we did with Zen 4 is we implemented using a double pumping of a 256-bit data width. And that is really to design in such a way that you avoid large frequency fluctuations when you have such switching activity with 512-bit workloads being executed. Using AVX 512, we see up to a 1.3x improvement of 32-bit precision floating point inferencing operations. And that's versus, of course, our previous Zen 3 generation. And with this kind of capability, we can target heavy lifting HPC workloads as well, like molecular simulation, ray tracing, physics simulators, and the like. As part of adding support for AVX 512 implementation, we added extensions for convolutional neural nets with the vector neural net instructions, VNNI. In desktop applications, the Ryzen 7000 series with VNNI support and the INT8 approximate math format delivers a 2.5x improvement over Ryzen 5000 series CPUs. It's a huge speed up for applications like image processing and natural language processing. Now let's take a look at the overall performance and performance per watt gains. Our decades-long relationship with TSMC and our EDA partners continues with 5 nanometer. We operate in a deep design technology co-optimization partnership that really synergistically makes certain that the design and the process changes work harmoniously together to deliver performance and efficiency gains, and that they're highly manufacturable. In Zen 4, the result was a specialized N5 HPC process that enabled additional frequency beyond the baseline process. The teams co-optimized the device scaling, the device capacitance, and the metal stack, making significant contributions to our overall Zen 4 performance. In addition to design levers to further improve our compute efficiency leadership. The logic and cache area scaling in the N5 allowed us to further reduce the die area over Zen 3 by 18%, despite adding new performance features and instruction support. A 15-layer telescoping metal stack has been co-optimized to deliver both high frequency and high density routing capability. The partnership around design and process delivers leadership efficiency for Zen 4. We continue our commitments to energy efficiency and high performance with every generation. The technology improvements include a 20% reduction in device capacitance, along with design improvements, really as a key enabler here. Zen 4 and desktop socket brings a 62% lower power at the same performance, or 49% more performance at the same power compared to Zen 3. AMD is committed to high performance with sustainability, reducing the environmental impact of our high performance processors. And this is quickly becoming a rising criteria across our customer base. The impact of Zen 4 and Ryzen 7000 series is fully evident in the performance gains. You look at the same across the TDP range here. The leadership N5 technology is a part of the reason we can deliver such huge gains. And of course, it's amplified by the IPC gains. And look at the 65-watt TDP. That's where N5 shines. We've really been able to deliver those IPC gains without compromising on power. Tremendous advantage. We've doubled down on our implementation efficiency, getting to a finer grain level of power optimization than ever before. And the power improvements at the lower power, like I show on that 65-watt TDP, are where the N5 is in its sweet spot. This means we deliver compelling performance at low TDP, incentivizing customers to save power and take advantage of efficient, cool, and quiet systems for leading-edge performance. 5 years ago, when we announced the first generation of Zen, I showed you that we were advantaged in area and power versus our competitors' x86 CPU. Well, we continue. In fact, we've grown that advantage. The AMD Zen 4 Core plus L2 complex is about 50% smaller than the competition. That's a choice. We chose to optimize both high performance and power efficiency. Rather than just throwing power and area at the problem, we've been able at AMD to achieve a balance of high frequency design that is power efficient using our methodology and our technology application. The end result is a leadership CPU with significantly better performance per watt of energy expended in a much smaller area. Going forward, we continue our focused execution on x86 CPU roadmap. We plan on releasing the Ryzen 7000 series desktop processors with 3D V-cache in the future, and that's great for memory-intensive workloads, as you've already seen in our previous generation V-cache. Our Zen 4C, it's a compact density that's an addition, it's a new swim lane to our cores roadmap, and it delivers the identical functionality of Zen 4 at about half of the core area. And that'll be coming out in the first half of 2023 in our server lineup. This core is workload optimized for applications that don't need to run at the highest frequency and can deliver even more computational efficiency. I'm also glad to share that we remain on track for Zen 5, featuring a new grounds-up core for 2024. Zen 5 will bring a combination of performance gains as well as further optimizations for the growing AI workloads. It's full speed ahead for our CPU innovations. Well, look, AMD is simply delivering with relentless focus on our Zen CPU roadmap, consistently on schedule and to our performance goals. Zen 4 is another testament to AMD R&D execution excellence. We remain focused on being the trusted partner for our customers, and our next generation of designs are well underway. With 5 nanometer process technology and design optimization, Zen 4 delivers. In desktop applications, it will not only bring performance leadership, but deliver that performance at a fraction of the power consumption of the competition. And I'll repeat a phrase I've said many times over the years. There will be no let-up in AMD innovation. Zen 4 and Ryzen 7000 series is a shining example of high-performance leadership delivered with an energy efficiency that our society wants and simply requires going forward. Thank you. Thank you, and I'd like to introduce David McAfee, who will come on stage here and share with us more detail about the AM5 platform.
Thanks, everyone. I'd like to dive a little bit deeper into the platform that surrounds all of the innovation that Mark just talked about. Let's start by taking a look back for a moment on the AM4 platform and reflecting on what an incredible feat of engineering it represents. First introduced in September of 2016, and now nearly 6 years later, it's still going strong. With AM4, we made a promise to maintain a stable platform which gave users the confidence that they could buy today and upgrade their system over time. While keeping the platform consistent, we drove incredible innovation into the socket. Innovation like 5 different CPU architectures across 4 process nodes, leading the market with next-generation I/O capabilities like PCI 4, and industry-first advances like chiplet architecture and 3D V-cache. Now, with over 125 processor models introduced and more than 500 motherboards, AM4 has transformed the expectations of desktop enthusiasts. As we turn our focus to the next generation of Ryzen desktops, our goal of creating a platform that grows with you remains consistent. Beginning with the 7000 series processors, powered by the industry-leading Zen 4 core, the AM5 platform brings a new level of capabilities built ready for the future. It all starts with a new 17-18-pin LGA socket designed to handle the next generation high-speed I/Os while making installation easier for the end user. We've expanded the socket power delivery to 230 watts to allow our Zen 4 processors to unlock the maximum all-core performance in the most demanding creator and gaming workloads, while still delivering clear leadership in performance per watt and power efficiency. AM5 is a platform that's built for the future, with next-generation technologies like DDR5 and PCI 5 to ensure that your build today meets your growing needs for years to come. And we've also designed a platform to leverage the best of our existing ecosystem, maintaining compatibility between today's diverse selection of AM4 coolers and our next generation AM5 platform. Every PC build is unique, and as we launch into AM5, we wanted to create a broad range of choices to best meet every user's needs. As we go into AM5, we'll offer 2 classes of motherboards, the X series and the B series. The X series boards, which will be available in September, are built to be uncompromising, with the highest power delivery and overclocking headroom across CPU and memory, along with the most I/O across the board. While every X series board will offer PCI 5 storage, X670 Extreme boards will enable PCIe 5 to graphics as well as storage slots on the board. We're also announcing our B-Series boards available in October, which strike the balance between enabling next-generation technologies and great value for the end user. Just like the X Series, you'll see B-Series Extreme boards, which offer similar capabilities with PCIe 5 graphics and storage. Now, speaking of PCIe 5 for a minute, let's talk about one of the first technologies coming to market in this cutting-edge I/O technology. PCIe 5 doubles the bandwidth for each lane on the board, unlocking the capability to drive substantially higher read and write performance and faster access when working with large and complex files. Starting in November of this year, PCIe 5 storage devices will be available from a wide range of partners around the globe. One of the other key design decisions in our AM5 platform was memory selection. And here we wanted to design a platform not just for today, but one that's built for tomorrow. And that's why DDR5 is the memory solution on our AM5 platform. DDR4 memory has been a great technology choice for gamers and creators for the past 5+ years, but it's also a technology which has reached the end of its evolution. First released in 2020, DDR5 picks up where DDR4 ends, with higher data rates to drive more bandwidth, the ability to deliver very low memory latency, and a roadmap to quadruple or more capacity per DIMM. It's clear that DDR5 is the right choice today and one that is built for the future as the technology continues to mature over time. Now, we know that Ryzen enthusiasts love to overclock their memory to ensure they're getting the fastest data rates and the lowest memory latency to maximize game performance. And that's why the AM5 platform is also being introduced with AMD Expo technology, or extended profiles for overclocking. Expo DIMMs enable one-click DDR5 overclocking for Ryzen AM5 builds, driving up to 11% faster gaming performance, lower latency down to 63 nanoseconds, and built on a standard that provides clear and open specifications to the end user so they know exactly what they're getting when they buy an Expo memory kit. As we launch into AM5, we expect to see over 15 Expo memory kits in market at launch, offered by the leading partners in high-performance memory overclocking and pushing the limits of DDR5 up to 6400 data rates even as we first enter the market. AM5 is the next generation of Ryzen, and it's a platform that we built for the future. This year, we expect to see motherboards in market starting from $125 to offer an incredibly wide range of price points to meet every system build needs. We've built the platform around next-generation technologies so that you can build today and upgrade as your needs grow over time. And just like AM4, we're making a commitment to support the AM5 platform with new technologies and next-generation architectures through at least 2025. I'm really excited about the next era of Ryzen desktops with AM5. Now let me bring Lisa back up on stage to recap today's news.
So thank you, David. We are so proud of what Ryzen 7000 CPUs are delivering on all of our ambitious goals. If you look at it, Ryzen 7000 delivers 11% faster single-threaded performance, 44% higher multi-threaded performance, and 47% more performance per watt than the competition. Now that you've seen everything that Ryzen 7000 series can do, I know you're all wondering about price and availability. Is that right? Okay, starting at the top of the stack, the 16-core 7950X is $699. The 12-core 7900X is $549. The 8-core is $399, and the 6-core 7600X is priced at $299. And all four of these will be on shelf worldwide on September 27th. Now, I mentioned earlier that it's a very exciting time for AMD as we bring 4 new architectures to market over the coming quarters. And while today was all about Ryzen 7000, of course we know gamers are always interested in what's coming next. So for all the gamers out there, I'm very excited that we have one more update for you today. This is our next generation Radeon graphics card powered by our all-new RDNA 3 architecture. It's very pretty. By combining our most advanced gaming architecture with 5-nanometer chiplets, RDNA 3 GPUs will deliver more than 50% more performance per watt than our current generation Radeon GPUs. And it's currently running in our labs. The performance looks absolutely wonderful. And so for the first time ever, let's take a look at RDNA 3 in action with the Ryzen 9 7950X. So what you're seeing here is the highly anticipated title Lies of P from our friends at Neowiz. This game was a breakout hit at Gamescom earlier this month based on its incredible visuals and gameplay. And what you're seeing is 4K gameplay at ultra settings running on a pre-production RDNA 3 GPU. Just take a look at it a bit. It looks absolutely wonderful, doesn't it? Now, we are feeling great about how RDNA 3 looks in the labs, and I can't wait to tell you more about it when we launch later this year. So let me wrap up here and say that we're so excited that you could join us today. Ryzen 7000 series is absolutely the world's first desktop processor in 5-nanometer. With the Zen 4 core, it's the fastest processor in the world for gaming and content creation. And with our new AM5 platform, it really brings the latest technologies for I/O and memory. It also brings our commitment for multi-year processor roadmap support and support through 2025 and beyond. So thank you to all the members of the press from around the world for joining us here in Austin today. We really appreciate it. And thank you to all of you who joined us online. It's been so much fun sharing with you how AMD and our partners continue to advance the PC experience. Thank you.